Hi everyone, welcome back to Life Technologies YouTube channel and thank you for watching. So this is a continuation of our Huawei Lab simulation series, and in our last few episodes we have discussed how to implement in the ASBRs MPLS IPVPN option A and option C. Option A and option B, that is. Remember we mentioned that we have three options. We have option A, option B and option C. With option A, we are doing back-to-back VRF peering between the ASBR, and we need to do VRF configuration on PEs and ASBRs in the network. With option B, we don't need to configure VRFs on the ASBR, but we need to configure a VPNv4 peering between the ASBRs. And then we are also enabling MPLS between the SBR. So for option A, remember, we don't do MPLS between the SBR. But with option B, we need to do MPLS configurations between the two SBRs. So we configure MPLS on the interface connecting SBR1 and SBR2. So the two options are not still efficient enough for service provider networks. Remember, with option A, it's not scalable. When you have many VRFs on your network, it means you need to do lots of configurations for those VRFs. Option B, it's slightly scalable, but then because we are not configuring VRFs between the ASBRs, but the two options, A and B, they still place a higher requirement on the ASBR. Remember, the ASBR still have to maintain the routing information or to keep the routing information from the customers. So if you have many number of routes on your network, you may end up having to have very high-end devices at the ASBR because the low-end devices will not be able to handle those number of routes. So that's why we are introducing option C. So in this episode, we'll be focusing on how to implement the IGP BGP MPLS IPVPN option C on Huawei routing devices. But before you watch this video, kindly watch the last two for option A and option B that will help you to understand why we need option C for service provider networks. So this is the topology that we are using. We have different nodes, we have different autonomous systems. So we have autonomous system 200 and 100, that is for the service provider network, and we have customers connecting to the two autonomous systems. So we have CE1 and CE3 connecting to autonomous system 200, and we have CE2 and CE4 connecting to autonomous system number 100. We will be using BGP as our PEC routing protocol, so we need to configure BGP peering session between the PEs and the CEs. And then for our two AS, 100 and 200, in S100 we have OSPF configured as our IGP, and we also need to enable MPLS and LDP within the autonomous system 100. In S200 we are using ISIS as our IGP. So remember, you can flexibly choose which IGP protocol to use. You can use ISIS, you can use RIP, you can use OSPF or EIGRP depending on your network design. And once we have reachability or connectivity between these two nodes, remember we have the PE connecting to P01 and then we have ASBR. So we need to ensure that we have connectivity between these two different nodes. And for the BGP configuration, we are doing what we call the BGP IPv4 label unicast. For example, between PE01 and SBR01, we are implementing the BGP IPv4 label unicast. And then between the SBR, we are not doing the VPNv4 peering as we did with option B. We are doing the label unicast, BGP label unicast between the SBR. So we need to configure BGP label unicast between the PEs and the SBR, and also between the SBR we are implementing BGP IPv4 label unicast. So remember, with option B we were doing BGP VPNv4 peering between the SBR and exchanging the VPN routes. With option C we have two options. The first solution is to do PE to PE VPNv4 peering. So we do MP-eBGP VPNv4 peering between the PEs. But this has some limitation. Remember, a service provider network can have so many PEs. So it means you need to do lots of configuration to ensure that you have the MP-eBGP VPNv4 peering between the PEs. So that is not scalable enough, and it will have limitation in the number of configuration and the session that you need to configure on your network. But then we have another solution that we'll be discussing in our next coming episodes. We introduce route reflectors in the network, and we only need to establish the MP-eBGP VPNv4 peering session between the route reflectors. So that is a solution that we'll be looking at in our next coming videos. But in this episode, we are just focusing on where we have the MP-eBGP peering session between PEs in the different autonomous systems. So this is the setup, and for the packet forwarding from the CE to PE, we have IP packet, and then we have an end-to-end tunnel established between the PE. So as opposed to option A and option B, with option C, we have an end-to-end LSP established from the PE in one autonomous system to the PE in another autonomous system. So MPLS label forwarding is performed from PEs to from the local PE to the remote PE. So this is the topology. I've explained it. We already have the setup ready in our ENSP. As I've mentioned, we are using the PE to CE. We are using BGP protocol. And then we are using OSPF, ISIS as our IGP in different autonomous systems. And we also need to enable MPLS and LDP in the network so that we have the label forwarding performed on our network. So for the configuration, before we go to the configuration step, we need to mention some key features of option C. So we have mentioned that option C is the most scalable solution. Remember, instead of doing the PE SBR VPNv4 peering or the SBR to SBR VPNv4 peering, we only need to establish PE to PE VPNv4 peerings. And then if we can introduce the RR, it becomes even more scalable because we only need to peer the PEs to the local RR. Then the RR will be in charge of distributing routes in our network. Another thing I need to mention about option C is that route targets are globally significant. So when we are configuring the route targets, we are using the same route targets on the PEs so that they can be able to exchange the routes. So they are globally significant in our network. Then we are implementing MPLS between the SBRs, same to option B. Then for BGP peering sessions, we are now doing direct peering between the PEs. So we are establishing a BGP peering session, the VPNv4 peering between the PEs. That's why you can see in the diagram, we have indicated that we have a BGP peering session between PE01 and PE02 directly. And then the PEs will be able to exchange the routes directly through the VPNv4 peering session. We don't do any VRF configuration on the ASBRs. We only configure VRFs on the PEs. Then BGP LU, the label unicast is configured between PEs to SBR and between SBRs. So for the label unicast, remember when you have a network and you have IGP running, for example, ISIS or SPF, and then you have implemented MPLS and LDP, labels will be assigned to any prefix that is learned via IGP. By default, all the IGP prefixes will have a label assigned to it. But then you have labels, you have some prefixes that we are learning via BGP. So with BGP LU, we are just assigning labels to the routes or the prefixes that we are learning via BGP. Those prefixes will not have labels assigned via LDP, so we need to use BGP. So that's why we are calling it BGP label unicast. It's BGPS, but we are assigning prefixes. We are assigning labels to the prefixes that we are learning via BGP. So for the BGP LU, we are implementing it between the PEs and ASBR. So you need to enable that functionality on the router. And also between the ASBR, we are using the label unicast. So if we have any exchange of routes between the ASBR, or if we are learning any BGP prefixes from the ASBR, then we'll also assign labels to them and help us to have end-to-end tunnel between the PEs. So the last thing to mention is that we have end-to-end tunnel established between the PEs. So we are using MPLS from end to end, and the inner label will remain the same. Remember, with option B, there was a change of the inner label when a packet is traversing SBR1 to SBR2. But with option C, as we will see later, we have an end-to-end tunnel, and the inner and the outer labels, the inner label is kept the same. Of course, the outer label will keep changing based on the label assigned by the uplink router. So for the configurations, we are doing almost similar configuration with option A and B. So I've already configured the basic setup, or I've left the basic setup the way it was when we are doing the option A. So the first step is to configure system names and interface IP addresses in S200. So this one we already went through. If you missed this session, you can watch our option A and option B, just to make you have a clear understanding of what is being implemented. And I will add the links for option A and B down there in our comment section. So on P01, we do the configuration sysname and assign interface IP addresses as shown. So we have loopback 0, and then we assign IP address on gig 00 and gig 001. On SBR1, we are also doing the same. Configure the sysname and then assign IP address on our loopback IP. Remember, we are using the loopback IP for our BGP session, so we need to assign this IP address, and then we'll be able to use it for our BGP sessions. Once we have done that, the next step is to configure IGP. So remember, in this setup, we are using ISIS as our IGP in S200. And once we have enabled it, we need to test reachability to ensure that we have reachability between different nodes. So we are configuring ISIS on the router, and we are enabling it on the interfaces that we need to advertise within our ISIS domain. So we configure the IS level. Uniformly, we use level 2. Course style, we are using wide, and then the network entity we generated from the loopback IP. Then we configure the IS name just to be able to easily identify this ISIS session on the peer device. So we have it configured. We enable it on the interface. We are enabling it on the interface in our MPLS backbone network. And then we can set the circuit type, either point-to-point or broadcast, depending on the requirements of the network. So we are doing the same configuration on P01, configure ISIS process, and then enable it on the interface. On SBR01, we are also doing the same. So we can verify that our ISIS status is up. I will log into these routers and verify. So from P1, we can display ISIS peer. You can see that we have a peering session to P01. I can display ISIS LSDB. We'll have the link state information in our LSDB. Can display IP routing table. So we have the routes that we have learned via ISIS. On P01, we need to verify the process is okay. Display ISIS peer. So we have ISIS to P01 and SBR01. Display ISIS LSDB. We also have these LSPs in our LSDB. Can display IP routing table. So we have route that we have learned via ISIS. Then on SBR1, we also need to verify display ISIS peer. We have one peering session to P01, then display ISIS interface, maybe just to verify that we have two interfaces, gig 00 and loopback 0. We have enabled ISIS, display IP routing table. We have routes learned via ISIS. So remember, the objective of running an IGP first is to ensure that we have reachability information between these different nodes. So we can verify that we can ping the loopback IP of our provider edge router 1. So we are able to ping. We can also ping the IP for our P router. So this one verify that we have reachability or connectivity between the different nodes in S200. So once we have done that, our next step is to now configure MPLS and MPLS LDP. So we need to configure MPLS. First, we need to configure MPLS LSRID and enable MPLS, and then we can enable MPLS and MPLS LDP on the interfaces in our MPLS backbone. So again, if you missed this configuration in our first step of implementing option A and B, you can go through it just so that you are familiar with this configuration. We haven't changed any configuration from option A to option B. The only change will be on the BGP configurations. So on P01, we do the same. We are enabling MPLS, configuring the LSRID, and enabling MPLS on the router and MPLS LDP. So once we have done that, we can enable MPLS on the interface, and you also need to enable MPLS on the interface facing the peer device. So we can verify that our MPLS LDP sessions are up. So on P01, can display MPLS LDP session. We have a session with P01, and you can see the status is operational. On SBR, I can also display MPLS LDP session. So we only have local session established with 3.3.3. On P01, we can verify that we have two sessions, display MPLS LDP session. So we have two sessions, one to provider edge 1 and another one to SBR01. So our MPLS, our LDP is well configured. We are ready to move to the next step. So for the next step, we now need to configure BGP label unicast peering session between PE01 and SBR01. So remember, I mentioned that we are using the label BGP LU between the PE and the SBRs. So that's why in this step, we are configuring the BGP label unicast peering session between the PEs and the SBR. And the only change that we are doing is this command. We are enabling the label route capability between the two peers. So you need to configure the router ID, configure the peer as usual, similar to option A and B. But now, remember, we are doing the IPv4 label unicast. So any route that will be running via BGP will be given a label. So that's what we are enabling with using the command label route capability. So you always have to remember this command when you are implementing option C. Without this command, you will not, some labels will not be assigned to the prefixes learned via BGP. So you need to remember this command, the peer x.x.x.x label route capability. So this is for PE1, and then we need to configure SBR01. So on SBR01, we are also enabling the label route capability between the two routers, the PE and the SBR. So we can verify that our session, our BGP LU is up. I will log into, on P1, we can display BGP peer. We haven't configured the BGP LU, so I will start running the configurations. So I will start with P01. We need to configure the BGP label unicast. We'll configure it, quit, just verify the configuration, display this. You have the configuration for label route capability. And then we'll do the same for our ASBR01. So for ASBR01, we will configure the label unicast between the PE and the ASBR. So if I display BGP peer, it will take some time before it comes up, so we need to give it some time. On P1, SBR1, BGP1 and 200, display these. So we have it configured. Let me run the command to check the status. Display BGP peer, it's not yet established, it's now up. So we have the BGP label unicast between the SBR and the PE. It's currently up. On P1, we can also verify that the session is up. Display BGP peer. Can 4.4.4 do verbose of it. So with this command, we can be able to verify that we have enabled label capability. So you can see that address family IPv4 unicast is advertised and received, and the address family IPv4 unicast label. So this is the label capability that we have enabled. It's advertised and received. So they will be able to advertise and exchange label routes between them. So on SBR1, we can also verify the same. Display BGP peer 2.2.2 verbose. You can see that address family IPv4 unicast label is advertised and received. So we have enabled two. We have IPv4 and then we have the label unicast. They are both enabled on these routers. And you can see many other details about this peering session. So once we have done that, we need to move to the next stage of our configuration. We have already ensured that our BGP peering session is up between the PE and the SBR. So we'll move to configure AS100. So AS100, we also need to do the interface configuration. We need to configure the sysname and assign IP address on the interfaces. So this is the configuration for SBR02. And then for P01, we do the same. We configure the sysname and assign IP address on the interfaces. So this one is already configured on the router and is similar to the one that we used for option A and B. So for P02, we do the same. Assign sysname and configure interface IPs. Once we have done that, we are now moving to the second stage of configuring our AS100. So remember, in AS100 we are using OSPF as our IGP, so we need to configure this OSPF process and enable or advertise the network that we need to be reachable from other routers. So we are configuring OSPF process 10 and we are using the Loopback IP as our router ID and advertising the Loopback network and also the interconnected network between the different nodes in our MPLS backbone. So these are the OSPF configuration that we need on P02, P02 and SBR02. So we can verify our OSPF status on these routers. I will log into SBR2. We can display OSPF peer. You can see that on this router we have one peering session, and this peering session is to our P02. Can display OSPF interface to ensure that we have OSPF enabled on Loopback interface and the interconnected interface between P01 and SBR02. Can display IP routing table. So we have learned some routes via OSPF. We can check on P01, P02, that is, let me open P02. So on P02, we can display IP routing table. We have OSPF route, display OSPF peer. We have two peering sessions. Two OSPF peering sessions have been established between P02 and PE02, and also P02 and our ASBR02 in this autonomous system. We can display OSPF interface. So we have these interfaces enabled with OSPF. Then the final confirmation is we need to also check SBR02. It should be P02. Display OSPF peer. We have one peering session. Display OSPF routing table. We have routing information. Display OSPF interface. Display OSPF interface. So we have these interfaces enabled with OSPF. So from P02 we should be able to ping the loopback IP of our SBR02. So I can try to ping 4.4.4. Let me confirm the loopback IP of it's 5.5.5. So on P02 I need to try and ping 5.5.5. It's reachable. Ping 6.6.6. So we have reachability within the autonomous system with our IGP, which we have configured OSPF in this AS100. So once we have done our OSPF configurations and we have reachability, we also need to configure MPLS and MPLS LDP on all routers in our autonomous system number 100. So these are the configurations similar to the previous one for option A and option B. No change that we have done on the configurations. So these one are already configured. We just need to verify that our MPLS LDP sessions are up on the routers. So we will verify the sessions. On P2 we can display MPLS LDP session. You can see that we have an MPLS session with SBR2 and PE2. On PE2 we also verify display MPLS LDP session. We have one session to P02. On SBR we also expect to have one session, display MPLS LDP session. We have one session to P02. So this one verify that our MPLS and LDP are well configured. Remember, we are using LDP as our signaling protocol. So the next step of our configuration is now to configure BGP LU, the label unicast peering session between SBR02 and PE02. So the same way we have done for PE01 and SBR02, we also need to configure BGP LU between the SBR and the PE. So this one is not configured. I need to configure it. And another reminder that you need to enable this label route capability when you are configuring the BGP LU between the routers. So I will copy this and log into SBR02. So if I display current configuration, display BGP peer, we don't have any BGP peering session. Display current configuration BGP, we don't have any BGP configuration. So on SBR2, let me just verify that I've picked the configuration for SBR2. Yes, those are the configuration for SBR2, so I need to configure it. Display this to verify that we have the right configuration. So we are peering to 7.7.7, which is PE2. Then for PE2, we also need to do similar configuration and establish a peering session to SBR2. So I will copy this, log into PE2, display BGP peer. We don't have any peering session, so we can now configure it. Paste, quit, display this. Remember, it's always a good practice to verify your configurations. So on this router, on the PEs, I haven't cleared the configuration for BGP peering session towards the CE. That's why we have the PE-CE configuration still intact. Display this, we have the configuration, display BGP peer. It's still idle. We expect it to come up. It's now up. It's established. So we can verify display BGP peer 5.5.5 bus, just to verify that we have address family IPv4 unicast label enabled. So on P2 we can do the same. Where is SBR2? So on SBR2 I can display BGP peer. We have a peering session to 7.7.7.7, and then we also need to verify that it is a unicast 7.7.7.7 verbose. We have address family IPv4 unicast label enabled. So it is IPv4 plus label unicast BGP peering session between the two. So once we have done that configuration, we now need to configure some route policies. We'll be configuring two route policies. The first route policy is just to apply MPLS label to the route that we are getting from the ASBR. So remember, ASBR, we are exchanging prefixes via BGP. So we need to ensure that those prefixes that are coming without a label, we will be adding a label on it before we advertise to the PE. And once we add the outer label on it, or with the inner label on it, we also need to perform another action. That's why we have two route policies. We have route policy apply MPLS label 1 and also apply MPLS label 2. And these policies will be applied to different directions. One will be applied towards the PE and another one towards the SBR. So I will configure these route policies to the SBR and later we'll apply them. So the second one means it's merging the MPLS label first, and then it will apply the another MPLS label. So it merges first and then applies another label on it. So these one are just on the ASBR, and if you don't have the route policies, you will not have your nodes exchanging the route. So you need to be able to apply this route policy configuration on the ASBRs before you can have communication between the different nodes. So I've configured the route policy. The next stage of our configuration is now to configure the label unicast between the ASBRs and bind export policies. So I've mentioned that we are binding two export policies, one to the PE and another one to the SBR. So instead of doing it separately, I've just configure the one for the PE and the one for the SBR on the same router. So I need to copy this for SBR1. As you can see, we are also enabling the route capability and the route capability between the SBRs. This one was already configured, so we don't need to repeat. The only command that we need to repeat is for this policy, so that if we have received a label route, we need to also apply a label on it, the outer label that will be used to forward the traffic. So on SBR, I will copy this. SBR1, we need to apply the configuration. So I will apply. Just display this to verify that we have right configurations. And then on SBR2 we also need to do some configuration. So we are peering to SBR1 and we are also applying a route policy towards the PE and the ASBR. So this is SBR2. I will configure this and verify that we have the right configuration. So we have the route policy apply MPLS export, and then toward the PE we are using the route policy apply MPLS label 2. So we need to match the incoming label and then we apply another label on it. So we can verify our peering session, display BGP peer. It will take some time to come up. It's now up. So we have to label unicast BGP peering session. One is to the ASBR and another one is to the PE. So on SBR1, we can also verify that our peering session is up, display BGP peer. So we have one to the PE and another one to the SBR. To the SBR, we can verify that it's also labeled unicast. We do verbose, so you can see that we have labeled unicast advertised and received. So we have configured our ASBRs. And remember, with option C, we are configuring BGP peering session between the PEs directly. And now we don't have any, we haven't advertised any loopbacks between the PEs. So PE01 doesn't know how to reach the loopback of PE02. And PE02 also doesn't know how to reach the loopback of PE01. So we need to have a way, a mechanism in which we can ensure that these two PEs can be able to reach. And we'll be using the loopback IP for us to be able to configure our BGP VPNv4 peering session between the two. So the best way is to advertise the loopback IPs on the ASBRs. So we'll be advertising the loopback IPs of the PEs on the ASBR. So, and these are the configurations. So we need to advertise this network, 2.2.2.2/32, and then 7.7.7 on the other ASBR. So I will start with configuring. So on P1, we can first verify that we don't have any routing information. Display BGP routing table. We don't have any. So we can configure it here. No, we need to configure it on the SBR, not on the PE. This was just to verify that we don't have. So I will rerun the command. And undo this network command. We don't need to advertise it here. But we can go to SBR1, display this. So we don't have any network advertised. We now need to advertise the network. On SBR2, display this. We don't have any network advertised. Display BGP routing table. We only have one that is coming in now from the remote device. We don't have 7.7.7 coming in from the local PE. So we need to configure this command to advertise the network of loopback of PE2 in our BGP network. So we can do this on SBR2. Once we have done this, we can verify that display BGP routing table. We have now the two networks that have been advertised to BGP. And now we should be able to ping between the SBR, between the PE routers. So on P2, if I try to ping 2.2.2.2, we are not able to ping. We need to source the loopback IP. Remember, we have only advertised the loopback IPs. So that's why we need to source -I loopback 0. So we can ping the loopback IP of the remote PE. On P1, we should also be able to display BGP routing table. We can get the 7.7.7. I can ping -I. We are sourcing the loopback. We need to ping 7.7.7.7. Loopback 0. So this one we are missing loopback 0. Okay. We are able to ping from the PE from the local PE to the remote PE. So we have reachability information. Now the final part of configuring our service provider network is just to configure the MP-eBGP VPNv4 peering session between the PEs. So that will be our second part, our next part of configuration, and we need to configure the MP-eBGP VPNv4 peering session between the PEs. And once we have configured, we also need to verify the status. So remember, this is eBGP. eBGP has what we call the maximum hops. So when we are doing eBGP, many times we do using the point-to-point interface because it's just one hop. So eBGP will always check the number of hops that we are using to establish eBGP peering session, and it's always set to 1. So the number of hops is always set to 1. That's why when you are doing this configuration, one thing that you need to pay attention to is this command, eBGP max hop. In our topology, this is P1, this is P2. We have multiple hops between these routers. We have 1, 2, 3, 4. In essence, we have 5 hops from P1 to P2. So we need to increase the number of hops for our eBGP peering session to come up. And if you miss that command, your eBGP peering session will fail to come up. So you need to be aware of that command and apply it when you are configuring the PEs. So on P1, I will run the configuration. So we are doing the VPNv4 peering between the two. And you also need to pay attention to the remote autonomous number. So I've done this configuration. I will now go ahead and configure P. This is P02, just a typo there. This should be on P02. We are peering to And another thing that you need to remember also is that we are using the loopback IP to peer the two PEs. So you need to ensure you run the command connect interface loopback 0. If you miss that command, you will not be able to establish the BGP peering session between the two nodes. So the two main commands that you need to remember is connect interface loopback 0, and you also need to do what? To ensure that you increase the number of hops that will be used to establish the eBGP peering sessions. So we can display BGP VPNv4 all peer. So we now have an eBGP peering session to our remote PE. On P1 we can do the same, display BGP VPNv4 all peer. We have also a remote peering session to our PE. We can do 7.7.7.7 verbose. This is a VPNv4 peering session. You can see that this one, we don't have the label unicast. We only have address family VPNv4 advertised and received. So this is only the VPNv4 peering session established between the PEs. So once we have done that, now the remaining part is easy. We need to configure VPN instances on our routers, the PE routers. Remember, again, we are not configuring VPN instances on the ASBR. We only do that on the PE routers. So this one helps reduce the number of configuration that we need to make, and it's very easy to implement, especially when you have many ASBRs. You don't need to configure them with the VPN instances. And another thing I need to mention that I've said that the route targets are globally significant, so you need to do proper planning for the route targets for the different VRFs and ensure that they are globally significant. They should be globally significant within the different autonomous system that you are implementing your entire ASBGP option C. So once we have configured the VRFs, this is already configured. I can verify that on our PEs. Can display current configuration, VPN instance. We have the two VRFs configured, VRF1 and VRF2. On this router, we can also do the same, display current configuration, VPN instance. We have the VPN instance configured, VRF1 and VRF2. on this PE02. So once we have done VRF configuration, now we need to configure the interface facing customer and bind the VRFs. Remember, the two routers are in different VRF. That is for the CE routers. So we have something is not working. So we have C1 in VRF1 and C3 in VRF2, and then we have C2 in VRF1 also, and C4 in VRF2. So the objective was to ensure that the CEs in the same VRF should be able to communicate without any problem, but those in a different VRF should not communicate. So these are the interface configuration. We are just configuring the interface facing the customer, binding the VRF instance, and assigning the IP address. So there is no change in this configuration for option A, option B, and option C. So once we have done that, we now need to configure BGP peering session between PEs and CE. Remember, we are using our BGP as our PE-CE protocol, so we need to configure BGP peering sessions between PEs and CEs. And these are the configuration, no change for option A, option B, and option C. And finally, we now need to configure our CEs. So for CE configuration, we need to configure the sysname, the interface facing the PE, enable loopback IP that will be used to simulate customer device, and then we can configure the BGP peering session and advertise the loopback IP to our BGP. So we can verify that our BGP sessions are up. On C1, I can display BGP peer. We have a BGP peering session between the two. On P2, display BGP peer. This is on C2. We have BGP peering session. On PEs, we can display BGP VPNv4 all peer. We have peering session to the CE in VRF1 and VRF2. On P1, we can also display BGP VPNv4 all peer. We have BGP session established in VRF1 and VRF2. So we have completed our configurations. Now we just need to, remember I also mentioned that we have an end-to-end LSP. So if I do display MPLS LSP on this router, you can see that we have an LSP to the remote PE. And similarly on P2, if I do display MPLS LSP, we also have an LSP to the remote PE. 2.2.2.2, and a label, the in and outer label are as shown. So the next step is now to verify that our peering session, not our peering session, that our CEs can communicate. On C1, I can display IP routing table. We have a route to 8.8.8.8. On C2, we also expect the same, display IP routing table. We have a route to 1.1.1. So are we able to ping? We can verify. Minus VPN instance. No, we are not using VRFs here. I just need to source loopback 0, and then I ping 1.1.1.1. Yeah, there we go. We can be able to communicate between the CEs. On C1, I'll do the same. Ping -I loopback IP of 0 and then 8.8.8, we are able to ping. On VRF2, we can also verify, display IP routing table. We have the routes ping -I loopback 0, 10.10.10.10. We are able to communicate between the CEs. On this router, we can also display IP routing table, and we can do a ping -I loopback 0 9.9.9. We are able to ping. So this one verify that our option C setup is okay and it's working fine. we have connectivity between the different CEs connected to different service provider autonomous system networks. So just as a recap, remember the main configuration changes we are doing is on BGP between the PEs and the SBR, and also between the SBR and the PE. So we do IPv4 label unicast BGP peering session between the PE and the SBR, and also BGP IPv4 label unicast between the SBRs. And we are establishing VPNv4, eBGP VPNv4 peering session between the PEs. So we configure VPNv4 peering between PE01 and PE02 instead of doing between the ASBRs. So that is the main change that we are doing in terms of configuration. Then another thing I need to mention again, you need to enable the label route capability between the two routers, the SBR and the PE, and also between the SBR. And for your BGP peering session between the PEs to come up, you also need to increase the number of hops for eBGP to establish the peering session, because we are using Loopback 0 IP. So you need to ensure that you increase the number of hops. Depending on the network, you can make it to 255, the maximum number, but you can set the number as per the requirement or as per your network setup. So this is it for our option C. I hope you have enjoyed the session. And remember, this is just solution 1. We have another solution where we are having route reflectors in the network. Instead of establishing BGP peering session between the PEs, we can just have route reflectors in every autonomous system, and we establish the normal peering session between PEs and the SBR, and then we have VPNv4 peering between the SBRs, the route reflectors. Then the route reflectors will be in charge of ensuring that routes are propagated to the PEs. So thank you again for watching, and if you have any question, feel free to reach out. Option C, it's kind of not easy to understand. You really need to first have a good background of how option A and option B works, and I encourage you to watch the 2 videos on option A and option B, and even try to understand how the packet flows between the 2 autonomous systems when you have option A and option B, and then it will be very easy for you to understand the implementation of option C and how the packet or the traffic flows between the different autonomous systems. So if you have any question about option C, the first solution, feel free to reach out. You can ping me on LinkedIn, and I'll be glad to help. If you need this topology setup, also feel free to reach out. I will share with you, and the scripts are also available on demand. So thank you for watching again, and please remember to subscribe to our channel and stay tuned for our upcoming video. So in our next episode, we'll be covering how a packet flow, the label flow information from C1 to C2. Remember, we have mentioned that the packet is labeled end-to-end from P1 to P2. So this is what we'll be covering in our next episode. Bye.